All right, we're going to get going here. Welcome, everyone. It is excellent to have you all here today for our event, Realizing Technology Innovations to Recirculate Plastics. Let me first introduce myself. I am George Roeder and the Managing Director of the Canada Plastics Pact, which is a collaborative effort to involve organizations across the value chain in realizing a circular economy for plastics in Canada. And we're one of the co-hosts of today's webinar, which is going to prove to be, I think, really interesting and stimulating for everyone. What I would love is if you're coming in and you want to introduce yourself, please open up the chat. You'll see the button at the bottom of your screen and just put your name in, your organization, maybe where in Canada or North America or the world you're joining us from, to introduce yourself to everyone here. And just make sure, as you do so, to select all panelists and attendees when you look in the drop-down box as you open up the chat, so that it sends to everyone here. Before we go any further, I'd just like to recognize that we're joining from all across Canada and maybe further afield. Each of us on the traditional territories of one or another First Nations. For those who are not from Canada, we have a tradition in Canada that has emerged of recognizing the traditional lands on which we are coming from as we gather together as large groups. So I am based here in Toronto, which is the traditional territory of the Mississauga of the Credit, the Anishinaabe, the Haudenosaunee, the Chippewa, and the Wendat peoples, and it is covered by Treaty 13. And there continue to be a large number of Indigenous peoples who are still in this area contributing greatly to society here. I'd love to just kind of go to the next slide and talk a bit about our agenda for today. So this welcome is where we are, and then we'll move into some introductions of 5 really excellent speakers who represent innovations from across the plastics value chain, who I think are going to really help highlight some of the opportunities they're exploring, some of the accomplishments they have, some of the challenges, and some of the barriers that they're seeing in achieving a circular economy for plastics. And then really have a moderated discussion to be able to dig deeper into some of those opportunities and challenge areas with an audience Q&A that will be part of this. If you go to the next slide, of course, we are on all the socials for this session. Please feel free to tag any number of these organizations that have been part of really presenting today's session, or to use the hashtag circular solutions to be able to tag this event either on LinkedIn or Twitter or whatever your preferred social channel is for the day. Before we go any further, we actually wanted to kick off the session by getting everybody here involved a little bit in giving your thoughts on where we're at right now in terms of a circular economy for plastics, and in particular, what the benefits are. So we're going to be using today a tool called Slido, and you'll see the link in the chat. Or if you go to slido.com, oftentimes panelists don't say pull out your cell phones, but this is an okay time. Pull out a cell phone, go to your browser or go to a browser window, and use the hashtag CESS Plastics 21, CESS Plastics 21, and you'll be able to put some answers in the poll. And we'll call this a warm-up poll for today because we'll be doing a few of these. So please head over to slido.com and put in CESS Plastics 21, and we'll just wait another 20 or 30 seconds. We have 50 people already who've jumped in, which is great. Let's see if we can get up over, let's say 130. Let's get a half of the folks answering. So we're definitely seeing the greatest benefit here around reducing plastics pollution in the environment, which quite a number of you have identified as the greatest benefit. Really interesting to see sort of reducing greenhouse gas emissions as part of this conversation as well. And I think that the panelists in the conversation will touch on all of these pieces over the day today. So that's great. Let's move on from that poll, and I'll hand the reins over to Elena, and she can take us from here. Over to you, Elena.
Thank you very much, George. So I'm Elena Mantagaris. I'm the Vice President of the Plastics Division for the Chemistry Industry Association of Canada, and I'll be moderating the discussion today, this session co-hosted with the CPP. Allow me to start off by introducing our speakers who come from quite a wide array along the plastics value chain, and who will be speaking to you about both the opportunities and challenges they see in advancing a circular economy for plastics. Let me start off by introducing Sarah Marshall. Sarah is the Director of Sustainability at Nova Chemicals and is responsible for leading cross-functional efforts to achieve the company's long-term vision for sustainability. She brings more than 20 years of R&D experience with the petrochemicals industry and has served at Nova in a variety of leadership roles. Joining her to speak about their joint initiative is David Lynch, who's the General Manager for Research and Development at enterchem. With more than 25 years of industry experience in advanced development and scale-up of products and manufacturing processes, David manages laboratory testing and pilot integration for enterchem's commercial process design. For the next initiative that we're going to be speaking about today, allow me to introduce 3 additional panelists. I'll start with Keith Bichard. Keith is the Chief Commercial Officer at Revital Polymers. Located in Sarnia, Ontario, Revital is one of the most advanced plastics recovery facilities in North America and a dependable end market for plastics packaging and products recovered in recycling programs in Ontario and across Canada and the United States. Joining the group is Ricardo Cuetos. Ricardo is the Vice President for Standards Products Americas at Ineos Styrolution America. Ricardo has held a career in various technical, commercial, and global sales positions at BASF Corporation and at Ineos Styrolution. He's responsible for produce management or production management, market development, sales, and technical services for North America. And finally, allow me to introduce Jocelyn Doucet. He is the co-founder and CEO at PyroWave. Jocelyn is a chemical engineer and an entrepreneur dedicated to the development and marketing of innovations in connection with the transition to the use of non-renewable resources in a circular economy business model. Thank you very much, panelists, for joining us here today. And we're going to start off with a brief overview of each initiative. So starting us off will be Sarah Marshall and David Lynch to speak about their initiative. Over to you.
Good afternoon, everybody. Let's flip to the next slide, and I'd like to take a brief moment to introduce Nova Chemicals and our role in the circular economy. Nova helps shape a world where products vital to our lives, to our health and happiness, are better tomorrow than they are today. And a large component of that now is our focus in the circular economy. We believe that through bold collaborations and partnerships, we can work to close the loop on the circular economy. And our strategy involves focus in product design for recyclability, mechanical recycling, and advanced recycling, which we'll talk to you about today. Nova is also the largest ethylene and polyethylene producer in Canada, and you can see a few more stats there related to the company on the slide. But without further ado, I'd like to turn it over now to my partner, David Lynch, to describe enterchem and the technology we're working on together. David.
Thanks, Sarah. So I'm David Lynch. I'm General Manager, Research and Development for enterchem. Enterchem is a Canadian-based company that focuses on carbon recycling solutions. So essentially what we do is we use a variety of different feedstocks. It could be it could be municipal waste, could be biomass residues, it could be mixed packaging or non-recycled plastics. We take the carbon from these various feedstocks and we convert that to basically intermediate products, being syngas, methanol, or ethanol, to address specific markets. And what we're working on with Nova is actually a solution to bring these intermediate products to downstream, basically ethylene. So if you want to go to the next slide. Sarah, I'll let you take this one away.
Sure. So our objective together, as David mentioned, is to take the syngas that is produced in enterchem's technology today and convert that into a one-step process to ethylene. Ethylene is the building block for polyethylene. And in the production of municipal solid waste through to syngas to ethylene, we create a circular economy, not only for plastics, but also for biomass, a component of municipal solid waste as well. So we are at an early research stage in the project and making excellent progress, which we look forward to talking about a bit more as the session progresses. David, before we pass it on, is there anything that I've missed here in the description?
No, I think that was a good summary. Thank you.
Okay.
Thank you, Sarah and David, for that overview of your initiative. Now I'm going to turn it over to the next group for Keith, Jocelyn, and Ricardo. I believe, Jocelyn, you're going to be presenting your slides for the group.
Sure, thanks for the introduction. On the next slide, it shows essentially what brought us together. So initially, we at PowerWave, we developed a technology that could convert polystyrene back into styrene monomer, which is the building block of polystyrene. And working with Styrolution, we were facing a challenge on feedstock sourcing. And so very early in the process, we would identify to work with Revital, who had this expertise in sourcing, sorting, and extracting plastic waste from different quality of feedstock. And since polystyrene is not as conventionally extracted from mixed plastics as it is for polypropylene or other types of resins, we had a little bit of research to do and try to validate whether we could do it. So on the next slide, it shows that essentially we've got a couple of takeaways from the project. So early on, we've tried to extract that material and prove that we're able to extract a quality of material that can be fed into advanced recycling technologies, which has been done with Revital support. And then using that feedstock, we've processed it with our microwave-based technology, and we've proven that we can actually convert it into recycled styrene monomer. And that styrene monomer can be reused in a variety of other styrenics, including polystyrene, but other styrene-containing product like ABS or adhesives. And that was done through the partnership with Styrolution's component, where they have this expertise in bringing to market styrenics and polystyrene and polymer in general. And at the end of the day, what we've shown is something that was not proven before, that there is a clear path that makes polystyrene recyclable at industrial scale. So on the next slide, it shows that essentially there are a couple of elements now that we're facing as an obstacle. So basically, we show that the technology exists, so we're able to, on the front end, extract the raw material from the variety of different type of polymers, and then the second time, we're able to convert it into a commodity that has market value and that has strong demand on the markets. But now we need to have that material being collected. So one of the point that we're really going to emphasize on is that we need to get access to feedstock. And so there are certainly some system-wide investment needed to be able to have these infrastructure in place for collection, sorting, and preparation, since we've proven we can do it. On the second front, we need to also create some additional demand for recycled products that also is going to drive the economics in favor of recycled product. And that's probably done by the proper policies and regulation that will increase the use of recycled content into virgin products. And finally, we need to also push adoption of innovation. And that's only done through collaboration within the different players of the value chain. Circular economy is possible when you put different people from the different element of the value chain working together, and that is also true in this case. And so we'll talk a bit more later in this conversation that how we can work together and bring these technologies to market.
Thank you, Jocelyn, for that overview of your project. I'll ask all panelists now to make yourselves visible on screen. And we'll turn to the next part of our agenda, which is the moderated discussion. So, I'm reflecting on the broad array of companies that you represent along the plastics value chain, and your partnerships are two great examples of collaborations that have pulled together different skills and expertise from distinct segments of the plastics value chain to achieve this common goal on circular economy. So what did you actually see in each other? Like, what opportunity or expertise did you see in each other that led to the discussions and brought you together? And what are some of the synergies that you've actually been able to leverage as a result of working together? Maybe I'll start with Sarah and David. I think Jocelyn partially answered this in his presentation, but let's start with you, Sarah and David. What brought you together, and what are those synergies and successes that you can already point to?
Sure. Well, actually, David and I met probably 4 years ago when I had a chance to tour the enterchem facility, which is a 3-hour drive up the road from Calgary, where I'm based. So we had some commonalities right from the start in terms of both having a presence in Alberta and both having actually quite sophisticated catalyst research technology groups within our companies. And when we were speaking together and looking at, as time progressed, the opportunities for innovation in the circular economy, we agreed that we could make very strong partners in the development of an alternative advanced recycling technology, which is the conversion of municipal solid waste, including mixed plastic waste as a potential in that feedstock, through the gasification process back directly into monomer feedstock for a polymerization process. So Nova has the catalyst researchers, we have laboratory facilities here in Alberta, and we have the assets at which to scale this technology just outside of Red Deer. And in Enterchem's case, their commercial scale facility in Edmonton and their research teams. So it began a great discussion that has progressed to a very strong joint development agreement since about this time last year, I would say. We've been at it for a year now together.
So David and Sarah, you mentioned early stage research still, but David, have you seen some synergies, some successes that you can point to?
Absolutely. So as Sarah mentioned, both companies, Nova and Enterchem, had strong research backgrounds and a lot of just a very innovative spirit about addressing this challenge. So we have a commercial facility here in Edmonton that's already taking upwards of 20 to 30,000 tons a year of non-recycled plastic that's just mixed in with the waste. Some of this could be laminated plastics or plastics mixed in with other packaging that's just really difficult to recycle. And I think that Enterchem and Nova saw together that if we could leverage the Enterchem process and a lot of what we were doing already and utilize syngas to go into downstream monomers, we could bring a brand new solution to market, and we were both very well positioned to do that.
Yeah, no, it's great opportunity. Maybe I'll turn to Ricardo and ask you to speak on behalf of the group. What brought these three of you together for this initiative? What did you see as the opportunity here?
Yeah, as Jocelyn started, Elena mentioning before, I mean, we see the complement of the supply chain because recycling and collection and solving the problem, as you know, that waste on the environment, nobody likes waste on the environment, not even in the seas and everything. So we see the synergies together of working with collection and sorting and all these new, good capabilities that we have with Revital. And we were thrilled, as Sarah mentioned, I met Jocelyn like 4 or 5 years ago, and when he described the technology, we were very engaged on that technology, especially for polystyrene. And it's for not only polystyrene, rigid polystyrene, it's for all polystyrene types, CPS, rigid, and GPPS, high impact. So we were thrilled on that one and see that this is a great solution because we get the whole supply chain together and get those synergies to make sure that we avoid bring the value to the polystyrene and solve the waste issue that we're facing in the food packaging industry. Mm-hmm.
You know, if nothing else, what it tells me is that there's no one company that can solve the circular economy for plastics on its own. The level of expertise and collaboration that's needed is significant and represented here in this group already. So, you know, this whole webinar, as you all know, is framed as a discussion on both the opportunities and the challenges in achieving a circular economy. And you've just spoken to the opportunity that's presented by working together. When you look at what's going to be needed to achieve success and you think about the future, what does that roadmap look like? I thought it might be helpful if we could just give our audience a bit of a visual to help them understand the opportunity and challenges ahead. So I'm going to give you three options, and I'm going to ask you guys to pick one of how you imagine the future. Do you see the future as this smooth, even terrain unfolding before your very eyes, sort of a steady walk to the destination? Or do you see a number of pitfalls or sinkholes with unanticipated challenges ahead of you? And maybe a third option to consider, is it a rolling set of hills to climb, but that you see the hilltops, they're in view, and you have a clear sense of what it takes to get to the goal? Curious about your perspectives on the future. Maybe I'll start with Keith.
Thanks, Ellen. You gave me three options, and I'm going to choose none of the above, I'm afraid.
Oh, okay.
So, well, the terrain is smooth, except when it's not, really. Yeah. The walk is steady, but it's mostly uphill. The pitfalls and the sinkholes, we know what they are. They're poor package design. They are lack of recovery infrastructure and advanced recovery technology that's not yet to scale. And this is all occurring in an environment that's unfavorable to recyclers. For we know that fossil-based plastics are inherently cheaper and will always be cheaper than recycled resins.
Very complex but honest answer, Keith. I appreciate it. Should have known you would have been the first out the gate with that. So how about I turn it? I'll stick with your team there. Jocelyn, how about you? What do you see as the future?
Well, what I keep in mind is looking forward, because if I was looking back, and I said this looks like a roller coaster. So we've been involved in developing a technology from the start. So that's a real bootstrap adventure. But I'd say that, just following what Keith said, I think we know what the challenges are. So I think that's pretty clear. I think we know what works and what doesn't work. I think we've solved the technology part. And now we know what's missing in the equation to make it work. And we'll address that later, I guess. But some policy framework for sure, more infrastructure. I think now we're trying to find where the material is, and now our processes are scaling, but yet they have to be fed with the proper material. So these are the challenges, but at least we know what the challenges are. So I guess hopefully the roller coaster comes to an end, but that's my view.
You're right. The good news is at least you know what the challenges are, right? That's half the battle to solving it. Maybe in the interest of time, I'll just ask David from enterchem, as what do you see as the path ahead?
Well, definitely more along the rolling hills and heading up the mountain. But just to add on to what Keith and Jocelyn said, there's a lot of work to be done. It's definitely an uphill climb. I think one of the challenges that maybe hasn't been mentioned is just the diversity of policies. You're dealing with a lot of municipal level decision makers and how things are recycled and how to address markets, how to get current mechanically recycled materials to markets, and what do we do with the rest of this stuff, and what's the composition of the rest of that stuff. And I think those are some of the things that we're dealing with specific solutions that we think can be applied to the broader market. But there's going to be some work to be done on the policy side just to kind of align what's being done, what's being practiced on the municipal level, and to bring that more in line across the board.
So that's helpful, and I've heard in each of those responses a little bit of a hint, I guess, is around where you might want to see some changes to help enable that circular economy. Let's take a little bit of a deeper dive into that question and some of the challenges that you see. So, you guys all had this idea, you envisioned this path forward, you brought your expertise together, and then what happens as the project progresses? What did you see as those challenges, or what do you continue to see as the challenges? Are they policy and regulatory challenges? Are there human resource challenges? How about financing? And what about just the simple conundrum of needing time for human ingenuity or technological innovation to actually come up with the solution to the challenge? If you were to choose one, what would you see as the top challenge going forward? So maybe I'll turn over to Ricardo to ask you to answer that question.
Well, I mean, I think, Elena, that's a very good question. But I mean, I would say all of the above, basically. I mean, in our view as a, a resin producer and also, like a chemical producer on a global basis, I see policy challenges, one of the key ones as well, and also financial. But I mean, the problem is the misperception about plastics. If plastics were created right now, will gain a sustainability, award, because we create good benefits for life. You can see on the pandemic of COVID, all the vaccines carry with EPS and those products. So I think that's the one, and we have to work together to really embrace the benefits of plastics to the society and also to the legislators and also to consumers. At the end of the day, that's a big challenge. Because you have to put the plastic in the right bin, and we have to collect and build the infrastructure to put it in the right way. And then with the technologies that we have created, you can recycle and really close the loop. So it's a combination in general, and we need to work together, as Jocelyn said. Look for the future, basically, and we are working hard to solve the problem as working together as a society, basically, not just as an industry.
So no simple, clear one thing, no silver bullet. I was in a meeting recently where somebody said there's no silver bullet, but there is silver buckshot. So exactly. I really loved that, because it's there's multiple things you need to go everywhere. I'm going to start using it more and more. And now all of you on the call can start using it as well. How about you, Sarah? What do you see as, if not the top challenge, at least a couple of key challenges to help enable the circular economy?
Sure. Well, Ellen, I might start the remarks by referring specifically to the advanced recycling innovation that enterchem and Nova are undertaking together, because that is one solution of many solutions for the circular economy. And in our particular project, we're starting at an early scale of innovation to actually address one of the challenges that Ricardo mentioned, which is the issue of having a decent quality feedstock for recycling. The gasification process brings the advantage of using a broader type of feedstock. So for example, bio-based carbon is a part of that feedstock, as is fossil-based carbon. So it gives us the advantage of thinking about a broader feedstock for carbon recycling. But on the flip side, this project is challenging because the innovation is significantly more expensive than creating virgin plastics today. And this is not an uncommon challenge for advanced recycling technologies. So the innovation gap that we have here is very much about how do we innovate to reduce the overall cost structure and create the benefits in the product, both the bio feedstock component, the fossil feedstock component. How do we also innovate for the future where we can integrate this type of facility into a much lower carbon producing petrochemicals complex? So some of these questions are big ones that our teams are living and working on today, because the solution, if it were available today, we'd see it at scale. But advanced recycling as a whole in Europe and in North America is just beginning to scale globally now. So we still do need these newer innovations in the pipeline, pushing forward progress and helping us scale these solutions for plastics.
So complex challenges, complex opportunities though. How about as recyclers, Keith and Jocelyn, mechanical and advanced recyclers, what would you identify as your key challenge? Keith?
I think that our key challenges are really about getting our supply. So we really need to have packaging that is recoverable. And that's working with the brand organizations who will design packaging from the outset to be recovered. So that is the number one opportunity that we have as both the mechanical recyclers and also our advanced recycling friends, and that we have material that we can actually recover. Infrastructure is the next item that we need to have in place, both the mechanical infrastructure, but also the government policy infrastructure that incents material to keep it out of the landfills and back into the recovery centers. And so those are the two things that I would look for most closely. And then the third item is to have incentives or regulations rather for the use of PCR, post-consumer resin, in virgin plastic. So if we have content levels that incent package and brand organizations to use PCR, that's going to be helpful for us in creating demand for PCR and improving the health of the recycling industry.
Thanks for that, Keith. So what I'm hearing is there are a lot of moving parts. We all have this aspirational goal, but in real time, all these pieces are not in place to help enable that end goal. And we're trying to create it all at once at the same time, whether it's policies or standards around PCR content, whether it's the technologies themselves, whether it's a whole slew of things. Maybe just a final word to you from an advanced recycler perspective. What do you see as your biggest challenge?
Yeah, so we're a technology licensor, so we are operating at scale. So we've gone all through all this scale up process, and we've tested our technology, and we're on this. So we are now at a point where we license the technology. And one key question, which I think summarizes all the questions, is how do you make this cost effective, and how do you make it cost competitive with virgin? And so there are two ways to do this. It's either you reduce the cost of the feedstock or you increase the value of the output. And there are two ways to do that in my mind. It's either through building infrastructure to compete against this optimized way of pumping oil from pipeline, which you cannot do for plastic waste. You have to pick it up by truck, and you have to sort it out with sorting facilities, which are not as scaled as they are as you see in refineries. And on the other side, you have to develop the demand for recycled product and a demand at higher price. And this is through policies and through minimum recycled content that you will drive that demand at higher price. And I think this is how these two things are essentially the same thing. It's all related to how do you make this cost competitive against virgin, which is really the issue here when it comes to licensing these processes.
So let's talk a little bit about what's needed then. One of the things I've heard is both the price differential that you've talked about, Jocelyn, but also the gap in infrastructure. And I noted with great interest that recently Minister McKenna issued a discussion document on the infrastructure needs of the future for this country. And one of the things highlighted in there was plastic waste recycling infrastructure. Thinking about that and thinking about the issues and challenges that you've identified, what do you think's actually needed to actually augment the existing, say, mechanical recycling infrastructures to optimal performance, or get to the point where advanced recycling can be catapulted more fully to full commercialization and deployment across the country? So maybe I'll stick with our recyclers on this webinar for a moment further. Keith, let's start with you again.
It really just does come back, Elena, to product as a package design. So if we have a package that is truly designed for recovery, then we are so far ahead where we are today. It's the number one thing that we should all be working on. And once we have that product package being designed for recovery, then having a greater number of facilities that have been optimized for recovery is the second thing that we need to get to. And finally, we should have an incentive to increase demand for PCR, and that's increasing the PCR content, putting a regulation, which really doesn't cost anything from an incentive point of view, but put in the opportunity to say that a certain percentage of new product should be PCR. Sorry, Elena, it was the same answer as last time.
No, that's fair. At least you're consistent, Keith. That's what matters. How about you, Jocelyn? Like, what does it take then to get advanced recycling to full deployment in the country to deal with? And, just as context for some of our audience, there's a sense that with the right investment in infrastructure for mechanical recycling, both, and I mean everything like sortation and mechanical recycling, we could probably deal with recycling about 50% of the plastics, right? What we need for that other 50% is advanced recycling. So you need both happening at the same time. And we've heard from Keith what's so critical, the product design side is so critical to getting to the quality feedstock that we need. How about you, Jocelyn? What does it take for that technology to be across the country?
Well, I'll do like Sarah, I'll just put a couple of precision here. So our process is very specific to a certain type of polymers. So we are dependent on the quality of the feedstock. So we need to have polystyrene on the input to be able to recover styrene on the output, which I think is different for the enterchem project. So here we're strongly dependent on the quality of the feedstock. And we need to have this advanced layer of mechanical sorting or purification, if you want. And I see that as an analogy, like think of this sorting facility or advanced facility like Revital is operating as a refinery for plastic waste. And this sorting and collection by truck is the pipeline equivalent. And your wells are individual houses where instead of pumping oil, you pump plastic from to the houses. And so what you do now is that you pick it up by truck and you sort it at Revital's facility, and then you extract all these different components like polypropylene, polyethylene, and whatnot. And these products now become the feedstock for middle stream processors, just like the output of a refinery becomes the raw material for middle stream chemical operators. And so this is how important that is. But the thing that we've demonstrated with this project is we know what are the sets of technology, what technologies are needed to do it, and they exist now. We don't have to invent them, and we need to develop a way to package them in the sense that we can deploy it on the territory and then allow for chemical or advanced technologies to be able to tap onto that material to feed their processes and then become truly circular.
Yeah, no, that's very helpful and really interesting. I guess, when I think a little further about some of the challenges and some of the opportunities we have ahead of us, Sarah, just, looking at, you mentioned that part of the attraction for you in working with enterchem is you're both located in Alberta and you represent a powerhouse then of opportunity geographically. When you look at the geographic dispersion of both our population and just, the geographies we have to think about when we're trying to put in place solutions, how do you see the opportunity in Canada? Do you think that we can create the type of momentum and initiative by creating regional hubs? And is the example of Nova and enterchem working together an example of a regionalization from a research perspective of an initiative?
Ellen, I think there's a lot more Canada can do, just period, on the issue of plastics. And one of the more powerful things that's happening across the country right now is the rollout and I guess we're past consultation, but the rollout of regulations related to extended producer responsibility for residential collection of recyclables. This is going to help in collecting more plastics for recycling, and will start to create more scale in the more dispersed areas of Canada that aren't the big cities like the Toronto, Montreal, Vancouver region, where there already is some decent scale. Beyond that, though, there's a lot of plastics that is used between business to business, and we call that the ICI sector. And there's still opportunity there to continue to collect that type of plastic. It happens to be some good quality materials for mechanical recycling, which is step one, if you will, in a hierarchy of you want to use as many materials as you can in mechanical recycling, and then continue to scale advanced recycling to deal with the more challenging materials after that. So I would say, yes, there's more going on that will lead to scale in the nation related to being able to build out what we could think of as hubs for recycling. And certainly Ontario and Alberta both have strength in the advanced recycling area as being close to the markets for the products. Because of course, the products of advanced recycling are the precursors to polymer production again. The final note I'll make, though, is Canada shouldn't think of itself as a closed system for plastics. We are heavily dependent on the US economy as well, and I fully expect that we will see integration north-south, east-west, and whatever way makes the most sense from a supply chain perspective so that we optimize economics in the system.
You've touched on a really important point there. Maybe two things I'll note for those who are unaware. When thinking about regional hubs, Alberta is a province that has indicated it wants to become a center of excellence for recycling for Western North America. So to Sarah's point, let's not just think domestically, let's think across the North American landscape. And maybe to that point, when I look at the technologies and innovations we're doing, should we not be thinking beyond our own borders? Should we not be thinking about the opportunities these technologies might represent for exporting elsewhere? And maybe Jocelyn is perhaps in the best position, or Ricardo, for talking about the international opportunity of being a leader in this space. Maybe over to you, Ricardo.
No, I think it's important. I mean, as you said, I mean, we need to keep and have a big vision. I mean, we are, as INEOS Starolution, we're supporting every single technology, basically, I mean, on a global basis, and we need to accelerate and deploy. I fully agree that we have a task by being the experts on each material to help with the design, in this case. And as I said, design something that it's a packaging for can be collected, as Keith mentioned, that's very important. But I mean, I think the plastic industry is global, and Canada, the view for domestic and then to expand is extremely important. And let's don't forget all these nice innovations that we have with enterchem, with Pyrowave, and many others, I mean, are coming from Canada. So we need to really, export that all over the world to really improve, the plastic waste solution, I mean, that we have and be careful with other alternatives as well. I mean, we really need to focus as well because carbon footprint and everything, I mean, has been a value item for us. So yeah, it's extremely important for us to really engage on this.
Jocelyn, anything you want to add to that?
Yeah, just one thing I may say. So I agree, and this is where we have most of our traction right now. So it's internationally. So we don't have penetration in the Canadian or North American market yet. It's really happening in Europe or Asia, in some jurisdiction where they have strong policies in place and they have strong demand. And one thing I would add, if we want to have an impact on plastic recycling or plastic greenhouse gas emissions by using recycle, I think we have a lot of value to put these technologies internationally as well, because we're importing a lot of that plastic from other countries. So we're not a big producer of plastic. I know Nova is here, a couple of Starolutions and Sarnia, but it's not a spread, it's not a huge sector of our economy. So we have, if we want to reduce our own impacts, we also have to deploy our technology to make our suppliers or people abroad that are shipping that material to our facility less carbon intensive or more circular.
So maybe the only thing I would say, Jocelyn, for those, again, joining us here today, at least in Canada, the sector as a whole is actually a $35 billion sector, employing about 100,000 people in this country. So it's got a certain heft and size in this country. And certainly with the chemistry sector combined, it is an $80 billion sector. And that makes us the third largest sector in this country. So still quite a bit of heft there, I think worth noting. In the interest of time, I'm going to ask one last big question and maybe a quick one. So my last big question, and this is a tough one because what I'm hearing today is, and what I see, of course, is we see governments, we see industry groups, other organizations setting really ambitious goals and targets for plastics recycling. And we all share that common goal, right? About realizing a circular economy. I didn't hear anyone offside with that goal. But how do we find that balance between holding ourselves accountable to striving continuously to achieve a goal while recognizing the very real challenges we face around the time required to develop innovative solutions and actually ensuring we have the human and financial resources in place, some of the challenges, the gaps that you've all noted. So we're trying to do a lot all at the same time. How do we balance that out? And maybe David, I'll turn over to you and Sarah to comment on this question.
I'll give it a go first. Sarah's been on the spot for a lot of this. I think we need to do it one step at a time, one project at a time, one technology at a time. We both have very high potential projects that we're looking to bring online with specific commercial deployments here in Canada. Jocelyn alluded to the opportunities internationally as well. Enterchem has a couple of projects that have been announced and are in advanced development in Europe as well, that are looking at these types of technologies as circular economy technologies, as chemical recycling technologies. And so I think you need to take it one project at a time, and then in 10 years from now, and we've got 1,000 projects to look back on, we'll say, wow, we came a long way. And I think that would be the way to proceed.
So maybe because of time, and I'm seeing the flag, maybe I'll just ask a very quick question with a rapid fire response, and I'll ask one person per initiative. So Sarah, for you, and maybe Jocelyn, what do each of you need to see in place to take your initiative to the next step? Sarah, let's start with you.
Well, for Nova to move to the next step, obviously, when you're in a research and development program, you need to see technoeconomic feasibility. And that means the technical goals and the milestone need to be met. And there's a line of sight to the business case to take the next step. And that's what we're working forward in this particular aspect of Nova's work in the circular economy with enterchem. The answer would be different if we talked about other circular economy initiatives, Elena, but just keeping to this advanced recycling project, that's how I'd answer you today.
That's fair. Thanks a lot, Sarah. Absolutely. Jocelyn, what do you need to see to take your initiative to the next step?
I agree with Sarah. It's all about the technical economic feasibility. And I think the policy is the main driver. Once you have the proper policies in place to drive demand, then you can build and ask for infrastructure to feed that demand. So I think it all comes down to policies, having minimum recycled content, having low carbon targets in plastics, things like that, packaging design criterions that make it more recyclable, more easily to collect and sort. I think these are all the policies that we can put in place, and that will have a strong impact on technologies and circularity in general.
Thank you all for a really great discussion and for not shying away, not only from the tough questions, but putting some honest answers on the table too. It sounds like we need a little bit of everything to make it work, and we need to work in collaboration to actually achieve that goal. So over to you, George, for Q&A.
Yeah, thanks so much, Elena and everybody. There's been a really robust discussion and a set of questions in the chat. Let me try to bucket a few of them together. And I would say there's one sort of broad thread around kind of questions around how much plastic we're putting on the market right now. And in particular, if we get better at recycling, does that actually incent more, which may ultimately also lead to a little bit more leakage and waste, and how do we get that balance right in sort of the messaging and as an industry our moves forward? So that wrapped up a few people's questions all in one, hopefully in a little bit of a box. So if anybody wants to tackle that.
Well, maybe I can jump on in and just say a few words. I think there are typically two issues with plastics, and one is, are we consuming too much of that material? And the second one is, are we dealing well with the end of life of that material? And I think it's unfair that people that are trying to deal with the end of life part are now responsible for the first part of the equation, which is making more. So we have decided to address this end of life situation, and probably at the end of the day, if you make it more circular, then people will consume more. But at the end of the day, we're not responsible for the entire value chain. I think if we're able to address that end of life issue in a sustainable way, in an efficient way, in a low carbon way, I think it's progress. Now, do we need to revisit how we deal with that material in the first place? I think there's a conversation to have, but we're dealing with this end of life situation, which I think is now pretty much figured out.
George, if I can maybe counter to Jocelyn's response just for a sec. The demand for plastic globally is really linked to per capita consumption. And as the global population grows and wealth increases, today's solutions that plastics provides in terms of the performance benefits and the cost benefit analysis means that plastic is still projected to grow globally. Now, will more recycled content create increased growth? Unlikely that will be the case. What will continue to have plastics growing is the solution that it provides relative to the per capita need globally. I think there's a vast amount of research we can still do to look for ways to prolong the life of plastic goods. There's been lots of discussion in the chat related to reuse models, for example, and what's the right type of product design so that we can use that material more often and then, like Keith says, effectively get it back into a recycling stream at its end of life too. There's a tremendous amount that we can do there, but I would not link recycled content growth to plastics growth overall. I think those are two fundamentally different trajectories.
Yeah,
Great.
and just to add to that, but
Yeah,
the idea is the more recycled content you can bring back into the market, back into the value stream, theoretically you should be able to reduce the virgin material coming onto the market. And that's really what the circular economy is about, is you know, being more responsible with the carbon that we've got in the biosphere where we are. And I think that we're all offering pretty impactful solutions to that.
Let me follow up. There's a bunch of questions, definitely about the feedstock, which all of you have touched on in some ways or another. So there's definitely a question around polystyrene and the trickiness of collecting that. I don't know if we want to touch on that. And then another question really around, we have all this plastic in landfills right now. Can we kind of mine that and use that as feedstock as a bit of a, out there idea?
Yeah, maybe, related to polystyrene, yes, indeed. That's a challenge. And we are basically, because polystyrene is a material that makes less in the waste stream. It's 2%, 1% actually. And people can talk about EPS, GPPS. We would love to get as much polystyrene we can get, and Keith won't let me lie on that one, because we have mechanical recycling and advanced recycling, and we want to make both very, a technical feasibility story to make economical viable, to get back to food service applications. So in this case, we have been working with different technology partners to help companies like Revital, for example, Tombra, with the specific technologies to sort polystyrene out of mixed-waste plastic stream with a selectivity up to 99.9%. So you can get polystyrene out, and not just polystyrene. You can even, from the polystyrene, you can get GPPS, EPPS, and HIPs out it, and then we can use that materials. So there's a room for a mechanical recycling, and let's not forget, with technologies like enterchem and like Paraway, for example, you have an infinite run on the circular economy. So actually, you can get that product without affecting mechanical properties and using many times. For example, if you have marine debris, those materials you cannot use anymore for mechanical recycling because they lost some mechanical properties, you can still put in advanced recycling process and recover basically the molecular structure to get into that level. So I think, that's one of the challenges. As we said, we need to work together on the whole supply chain together. So maybe Keith, you can complement that.
I would say, thank you, Ricardo. I would say that it's in all of our interests to keep plastics out of the natural environment. And that's what we all live to do. And that's certainly the oceans, rivers, and streams, but also the landfills. And a large proportion of what we create ends up in the landfill. And as a recycler, I can tell you that there isn't enough plastic to recycle. We work very hard to find plastic to fill our plant. And so the best thing that we could do is ensure that the plastic that's being collected, it actually gets to a recycling plant. And so we can then convert it mechanically or with a Jocelyn from an advanced recycling point of view back into the circular economy.
Great stuff. I'm conscious of time, so maybe one last brief question. We've touched a few times on energy consumption, and And just curious if somebody wants to touch on that, and in particular, why the technologies that you're working on right now are really sort of part of a net zero greenhouse gas solution.
Yeah, I can jump here. So the question related to energy, so for me, this is a given. Depolymerizing polymers is an endothermic reaction, requires energy to do the reverse action, so it has to consume energy. The question is what type of energy and how much energy? That's the question. So we are proposing an electrical solution with the highest efficiency, highest yield. So that's how we're able to beat some other similar technologies in our space, at least for polystyrene. Now, with respect to the impacts, and I'll go brief on that, we keep the styrene structure intact. So I see some people on the thread talking about fuel. That's true. So there are technologies that are really focused on fuel, which is essentially going to burn it. Here we do a very fancy process where you keep that structure of that material, the styrene monomer, intact. So you're able to return it very late in the value chain. So you're reusing it at the polymerization plant, not all the way back to the entry of the facility of the refinery, which is where you have to accumulate all these emissions going back through the same path. So this is where you're avoiding emissions by returning at a different point in the value chain, and this is what we're doing different.
Great stuff. So we're gonna finish it off there. Thanks for that, Jocelyn. We're gonna finish off with a couple of quick additional polls. So if we want to get the next one up on Slido, you can get your phones out again or your browsers and answer. And the question that we're going to be putting up there today, to finish. So first one, based on this conversation today, what's your biggest takeaway? And in just one word or maybe two words, related to driving a circular economy for plastics. So what's your biggest takeaway relating to driving a circular economy for plastics? Just one or two words, and we'll wait for a bunch of different ideas to come in. So complex is coming out as definitely a leading one. Innovation, feedstock, policy, a hope there. Silver buckshot I see as one. Design, collaboration, great. This is really excellent. Let's go to the next question, and this is our last poll, and we'll just have a final poll. You know, we are thinking this has been the first collaboration collaborative put on knowledge series session between the Canada Plastics Pact and the Chemistry Industry Association of Canada Plastics Division. Really interested to know what your interest is on a follow-up topic. So a second webinar and what that would look like. So if we could get some of your ideas there, that would be wonderful. And as you put in those final answers, let me say a huge thanks, first of all, to all of you for taking time out of your Mondays during the day to spend this time with us. A huge thank you to the panelists for spending your time and prepping for this and your thoughtful answers, and of course your tireless work on driving toward a circular economy for plastics in Canada. And then to my co-host, Elena, it was fantastic. First of many collaborations between the Canada Plastics Pact and CIAC, and a really great session. And then finally, I think we have one final slide of things you can see that are coming up from the Globe series and the CE Solution series. You can see a webinar on June 10th on mining and metals, which will really look at the role of data in advancing a more circular economy solution for metals in the automotive supply chain. And then in mid-September, you can look forward to the World Circular Economy Forum hosted by Canada in cyberspace, but by Canada in mid-September. So we hope to see everyone at one of those two events. The link is in the chat. Thank you all again, and have a wonderful afternoon. Bye for now.
Thank you.